Hello, welcome back. Today we're going to talk about language and thought, whether the language you speak influences the thoughts that you think. So we're currently in the part of the class where we are applying what we learned about core linguistics to all kinds of interesting topics about language. In this case, the topic being language and thought is part of the bigger topic of the psychology of language. How does language relate to our thinking processes, our cognitive processes, like you would study in psychology or cognitive science or neuroscience? So, here's the question. Does the language you speak affect the thoughts you think? It's actually a really common idea in our culture that this is true. It's common that people will believe that the language we speak exerts a huge influence on the thoughts we think, such that if we change the language we speak, maybe we can change the thoughts that we think. We're going to be looking at that idea in a detailed and critical way during the course of this part of the class. So as an example of this idea that the language you speak affects the thoughts you think, I'm going to show you a passage from this book 1984 by George Orwell. So in this book, there is a oppressive government which is designing a new language called Newspeak, which is designed to change the way the populace thinks. And this is the ideology that this tyrannical government has behind generating Newspeak. So they say the purpose of Newspeak was not only to provide a medium of expression for the worldview and mental habits proper to the devotees of Ingsoc, which is the ideology in the book, but to make all other modes of thought impossible. It was intended that when Newspeak had been adopted once and for all and Old Speak, which is the English that we currently speak now, forgotten, a heretical thought should be literally unthinkable, at least as so far as thought is dependent on words. Its vocabulary was so constructed as to give exact and often very subtle expression to every meaning that a party member could properly wish to express, while excluding all other meanings and also the possibility of arriving at them by indirect methods. So the idea that this government in the book has is that they will make everyone speak this language called Newspeak, and once they speak Newspeak, it will be literally impossible for them to think rebellious thoughts. We see another manifestation of this idea from a linguist named Benjamin Lee Whorf. So Benjamin Lee Whorf wrote that we dissect nature along the lines laid down by our native languages. So the way that we categorize things in nature, he says, is determined by our native languages. The categories and types that we isolate from the world of phenomena, we do not find there because they stare every observer in the face. On the contrary, the world is presented in a kaleidoscopic flux of impressions, which has to be organized by our minds. And this means largely by the linguistic system in our minds. Okay, so this is a hypothesis. This is an idea that says that basically language gives you categories. Those categories determine how you perceive the world. Okay, and the question we're going to be asking in the course of this lecture is we're going to be applying scientific experimentation. We're going to be reviewing the recent scientific literature on, oh really? Is this really true? Does your native language really determine the categories that you perceive? Here's another example of this idea, again from Benjamin Lee Whorf. And this has turned into a famous idea. So he wrote in 1956, we English speakers have the same word for falling snow, snow on the ground, snow packed hard like ice, whatever the situation may be. To an Eskimo, this all-inclusive word would be almost unthinkable. There's that idea of unthinkable thoughts again. He would say that falling snow, slushy snow, and so on are sensuously and operationally different things to contend with. He uses different words for them and for other kinds of snow. So the actual linguistic observation here is that in the Eskimo or Inuit languages, it is indeed the case that there is no hypernym that encompasses both the meanings of falling snow and snow on the ground. That's the actual linguistic observation behind this idea. But I would like to question the way that Benjamin Lee Whorf is presenting this here. So he says that in English, we don't have these distinctions among kinds of snow. But we actually do, if you think about it. We have words like snow, slush, sleet, blizzard, powder, hail, hardpack, flurry, dusting. Especially if you're someone who enjoys skiing, you have a lot of words for a lot of different kinds of snow, and maybe you don't really think about them as the same kind of thing. You might have heard this idea that Eskimos have like a dozen or 1,000 or 1,000,000 words for snow. That's actually not true. The actual linguistic observation here is just that, as I pointed out, the Inuit languages have two different roots for snow on the ground versus snow that's falling. That's aput versus qanik. And they don't have a hypernym that encompasses the two. They don't have 1,000,000 words for snow. The interesting observation is just that they don't have a superordinate category that encompasses both of these kinds of snow. So if anyone ever tells you the Eskimos have 1,000,000 words for snow, it's just not true. It's just false. And even if they did have all those words for snow, would we really draw strong conclusions about their way of thinking? So as we've seen in English, people that ski have lots of words for snow. Do they think about snow fundamentally different than everyone else? It's also the case that horse breeders have lots of names for kinds of horses. Botanists have lots of names for shapes of leaves. Interior decorators have lots of names for shades of mauve. College students have lots of names for being drunk or whatever. And so basically when you have expertise in some area, you often end up having lots of names for gradations of things in that area. And so basically, what conclusions would we really draw about the structure of thought based on this? It doesn't really seem like the Inuit languages are particularly outstanding or different from the kind of variation you see even within a language like English. Another related idea is that there might be untranslatable words. This is hearkening back to something I mentioned in our first lecture. So is it the case that there are untranslatable words? Is there a word in one language which cannot ever be translated into another language? If so, that would mean that maybe there's a thought that you can think in one language that you cannot think in another language. For example, in Spanish, there's this word duende, the mysterious power of an artwork to move someone. In Czech, there's this word litost, which is the agony and torment sparked by the sudden apperception of one's own misery. It's been claimed that these words are untranslatable. And you can see this nice list of 20 allegedly untranslatable words here. But is this really the case? Certainly there's no single word in English that corresponds to Spanish duende, at least I don't know of one, nor to Czech litost, but I was able to translate these things using paraphrases, using indirect means. So are there really concepts that can only be expressed in one language, or are all languages equally capable of expressing all meanings? So I was able to give translations for those words, so maybe they weren't untranslatable after all. It could be the case that maybe the language we speak only affects the way we talk, and it doesn't affect our other thought or our other behavior. That would be a claim against Benjamin Lee Whorf's hypothesis, against what the government in 1984, the novel, was saying. If this is true, then it's not the case that your language circumscribes your thought. Rather, your language just determines the way you talk. And the way you think is not particularly affected by your language. In support of this idea, notice that it is often hard to put your thoughts into words. You've all had the experience of thinking something and not being able to express it in language, of thinking something and then you try to explain it to your friend and it just comes out really confusing, right? So we've all had this experience of thinking things we can't put into language. If that's the case, then how could it be that our language is actually constraining our thought, right? So maybe our thoughts are independent of the language we speak. So this leads us into a big debate within the field of linguistics, the debate about linguistic relativity. And I'd like to emphasize that this is an area where there's a lot of ongoing research. So you should bear in mind that the things I'm telling you about are simply our state of knowledge as of now, as of 2021. It could be the case that in future work, we will revise our thinking. We're doing science here. Science is a process of organized experimentation, organized doubt, organized criticism of existing ideas in order to produce better, more true ideas. And I am simply presenting the state of the art now. So the linguistic relativity hypothesis is the idea, which we saw reflected in Benjamin Lee Whorf and George Orwell, that the language someone speaks affects how they think and perceive the world. This is also called the Sapir-Whorf hypothesis. So it's named after that guy Benjamin Whorf and another earlier linguist named Sapir. We can differentiate between two versions of the Sapir-Whorf hypothesis. There's the strong Sapir-Whorf hypothesis, which says that the language you speak determines the thoughts you can think. So this means that there might actually be a thought that a speaker of one language can think that a speaker of another language cannot think. So the strong Sapir-Whorf hypothesis says that language actually limits your thought. It determines your thought. This is also called linguistic determinism. It's a particularly strong form of linguistic relativity. We can also distinguish something called the weak Sapir-Whorf hypothesis. The weak Sapir-Whorf hypothesis is that the language you speak has some influence on the thoughts you think and the way you perceive the world, but it doesn't limit your thoughts. It doesn't fully determine your perceptions. It's just that it exerts some potentially small influence. So just to clarify, what we're talking about here is the influence of the language you speak on the thoughts you think. So in your head, there are thoughts, right? And when you talk, you're producing language. Now, it's obvious that the thoughts you think affect the language that you produce, because usually when we're talking, we're expressing our thoughts. So there's no doubt that there is a connection between the thoughts you think and the language that you end up producing. Linguistic relativity says that maybe there's a sort of feedback where the language you speak actually feeds back and affects the thoughts you think. And remember, linguistic relativity is a hypothesis. We don't really know whether it's true or not. We know that your thoughts affect language. We don't really know whether your language affects your thoughts. So here's the basic status of linguistic relativity based on the current experimental knowledge. The strong Sapir-Whorf hypothesis, remember, that's the idea that the language you speak fully determines and limits the thoughts you think. The weak Sapir-Whorf hypothesis says that the language you speak has some influence, potentially a small influence, on the thoughts you think. The strong Sapir-Whorf hypothesis is more or less ruled out by current experiments that have been conducted. However, the weak Sapir-Whorf hypothesis does appear to be true, although the effects are subtle. So based on the current state of knowledge, it looks like the language you speak does not determine the thoughts you think. So thought is to some extent independent of language, but the language you speak does have some influence, a particularly subtle influence on the thoughts that you think. So how would you test this? How would you test this idea? So the general procedure, which linguists have followed, is that you find two languages that differ in some way about how they describe the world. So maybe you find two languages that categorize things in the world in two different ways. Then you do experiments on speakers of those different languages to determine if they think and perceive the world differently. So we're going to today look at results from applying this procedure to the different ways that languages categorize the space of possible colors. So when you see the world, you see all kinds of different color percepts. And in language, we have words for color like red and green and blue and brown. We divide up this continuous space of all the possible colors into these discrete categories. It turns out that different languages do it differently. The boundaries between color categories are different from language to language, as we're going to see. This kind of work has also been performed for things like words for numbers. Languages differ in terms of how they describe numerosities of things, and also words for spatial relations and words for time relations. These are all areas where languages sort of carve up the categories of nature differently. And you can do experiments to see if speakers of these languages actually think differently. So, how do languages describe the world? Languages differ in how they describe the world. And this is not just a matter of the words that you use. So the words you use are a major way in which languages differ from another. So the lexicon of a language refers to what words and categories are available within a language. So for example, we're going to be looking at these color categories. Different languages have different lexicons for color. Languages also differ in something called metaphors, they differ in what underlying metaphors they use to describe events. So, for example, in English, we think about the past as being behind us and the future as being in front of us. So when we say something happened before something else, when we say something preceded something else, then we're using a metaphor where we are thinking about time relations in terms of spatial relations. Different languages do this differently. Languages also differ in what's called marking. So marking is what categories must be expressed according to the grammar of a language. So for example, in many European languages, it is required to mark the gender on all nouns. So one of the ways in which languages differ would be whether or not gender marking is required, and you can ask whether that changes the way that speakers think about objects based on their required gender marking. Okay, so now let's turn to words for color, and particularly the ways that color lexicons vary from language to language, and how that might affect how people perceive colors. So remember, languages differ in what words are available and how things are classified. And color categories are the classic example of this. So the possible colors you can perceive with your eye form a continuum that looks like this. So here I've divided the continuum into many particular colors. And you can see that there are many more colors here than we have names for in any natural language. So what would you call this? What would you call the colors that are in this circle? What would you call that? I think you'd probably call it yellow. How about this? What would you call these colors? I think you'd probably call them blue. So we see that different languages are grouping together these fine-grained colors into different categories. What would you call this? You'd probably call it green. The English color categories carve up the space of possible colors basically like this. So these reflect the major color categories as expressed using words in the English language. So we have red, orange, brown, yellow, green, blue, pink, purple. And you can see how those correspond to these different areas of the color space. You can think about the space of all the possible color percepts as forming a space which looks like this. So another way of visualizing this is to draw a figure that looks like this. This indicates the way that the English language divides up the continuous color space into categories. You can see that there's a big space which is identified as green, there's a big space identified as blue, and so on. So when you see a color like this, and then you see a color like this, and I ask you, are they the same color? You're probably going to say they are different colors because one's blue and one's green. But how about this? What if I show you this color, and then I show you this one, and ask you if they're the same color? You might say no. You might say they're both blue. So in some sense, you are perceiving, or you are maybe conceiving of the two colors on top as different and the two colors on the bottom as the same. So here's an interesting question. You probably agree that the two ones on top really look very different, and the two ones on the bottom really look really similar, right? You can tell that there's a little difference in the luminance there, but I think we can agree that the two on top look different than the two on the bottom. So is that because they are really perceptually different? Is that because the wavelengths of the light are really different? Or is it because you have learned as an English speaker to think of these things as different? So are these really perceptually different, or is that just the English language which has taught you to think of these things as different? Here's another language. Here are the color categories in another language. This is a language called Berinmo, which is spoken on Papua New Guinea by a very, very small hunter-gatherer group. And these are the color categories in Berinmo. So the interesting colors here are what is called war, which is kind of like this yellowish thing on the map, and what's called null here, which is a color category that simultaneously encompasses blue and green and certain shades of sort of greenish yellow, as you would describe them in English. So null is this category, war is this category. So the Berinmo language is carving up the space of colors differently from the English language. Now, here's a possible color. Here's another possible color. If you ask a Berinmo speaker, are they the same color? They're going to say yes, they're both null. These are both null. They're two different shades of null, according to a Berinmo speaker. So null is this category which we often call GRU. It's a color category that encompasses both green and blue. We have a special name for this, GRU, because many languages have a color category which simultaneously encompasses green and blue. So in order to document the variation in words for color across languages, there was a massive effort carried out starting in the 1960s called the World Color Survey. So this was a massive effort by linguists to interview people, speakers of many, many diverse languages, many languages spoken by small hunter-gatherer groups. The goal was to figure out what the boundaries of their color categories were. So you would go to people and show them one of these color chips, one of these specific color chips. You'd ask, what color is that? And you can draw this map. You can draw how those languages divide the color space into color categories. So this was led by Paul Kay and Brent Berlin. They started off by interviewing people and speakers of interesting languages in the Bay Area in California, and then they expanded it to the entire world. They managed to get data from 110 languages, many from non-industrial cultures carried out mostly by anthropologists. So they discovered a lot of interesting patterns in terms of how languages divide up this color space. It turns out that there is what's called a progression of color terms. So you can see, you can categorize languages in terms of just how many words they have for different colors. And then it turns out that when they have like 2 words, they divide up the color space in one particular way. When they have 3, they typically divide it up in another, and so on and so on. So when you have a language that has 2 color words, only 2 different words for color, so you don't have words for all the gradations of like green, blue, red, you just have 2 words for different colors, then those 2 colors end up meaning something like warm and cool, which is also sometimes translated as white and black. So for example, the Dani language, this is another language spoken by a group in Papua New Guinea, they only have 2 words for color. There's mola, which means warm or bright or white, and there's mili, which means cool or dark or black. So these are the category boundaries. Essentially, the colors on top of this line are called mola, and the ones below it are called mili. So when a language has 2 color categories, it typically divides it into warm and cool, or white and black. So what are the categories you would get in a language that has 3 color terms? When you have 3 color terms, the division you usually get is white versus black versus red. So for example, the Ejegam language spoken in Nigeria divides up the color space like this. The colors at the top of the space are called white. The colors at the bottom and in the middle are called black. And there's a category red, which also encompasses the things that in English we would call like pink and purple. How about when you have 4 color terms? So you can see that we're imagining the language is getting more and more color terms, and you can ask, what are the categories? What are the actual categories that it adds when it adds a new color term? So when you have 4 color words, typically you will distinguish black, white, red, and yellow. So the Colina language spoken in Peru here, you can see that it divides the space up into white at the top, black towards the bottom and the middle. Red is again something that encompasses what in English we would call red and pink and purple. And there's also a category yellow. And you can see that the yellow category encompasses a lot of colors that we would in English call like light green, light blue. So approximately we say this means yellow, but you can see that the color space is being divided up in a more interesting way. How about when you have 5 terms? What are the color categories that you get when you have 5 color terms? Typically, this is where you get GRU, this category that combines green and blue. So when you have 5 color words, you usually have black, white, red, yellow, and GRU. So for example, the Iduna language, another Papua New Guinea language, divides up the color space like this. This actually now looks pretty similar to the English color space, with the exception that there's no distinction between green and blue. That's this big GRU category in the middle. This is also a characteristic of, so for example, classical Chinese and Old Japanese have a color category that encompasses both green and blue. And it's only more recently that the languages have developed different terms that distinguish green from blue. Now, how about when you have 6 color terms? In that case, you're usually going to distinguish black, white, red, yellow, green, and blue. So GRU will split into green and blue. So the Buglere language here has 6 color categories. And its color space is looking more and more like English and the other languages spoken by industrialized cultures. Okay, so let's now look at Berinmo again. Berinmo is a really interesting language because it has these 2 color categories, null and war. And the boundaries of these categories are actually not the typical boundaries for these kinds of categories. So the null category, that's GRU, actually encompasses more colors, more sort of yellowish colors than you typically get in a GRU category. And the war category is correspondingly smaller. So let's say you show a Berinmo speaker this color. Then you show them this color. You ask, are they the same? They're going to say yes. Those are 2 different shades of war. But as an English speaker, I think that you would probably say that one of these is yellow and one is green. These are 2 colors which sort of barely straddle the line between yellow and green for English speakers. On the other hand, if you show Berinmo speakers this thing, and then this thing, 2 colors that English speakers, I think, would pretty resoundingly say are 2 different shades of green, they're going to say no. No, the one on the left is null and the other one is war, 2 different colors. So we see that the boundaries in Berinmo are different. There's a color category boundary that goes through this sort of yellow-green region, which exists in Berinmo, does not exist in English. So we've identified some interesting variants in languages in terms of how they categorize the world, how they carve up nature into color categories. Now I want to look at some experiments where we're trying to figure out, do people actually perceive colors as different? Do they think about colors differently as a result of their language? So is it the case that Berinmo speakers actually see those colors differently as determined by the categories of their language? Do they actually see the world differently from English speakers? Here is one task we can do to test whether there is some difference in the way Berinmo speakers are thinking as opposed to the way English speakers are thinking. We can do something called the chip sorting task. So what we do is you put a bunch of these color chips on a table. And then your task is to sort these into different categories. You see that these color chips are all one of 2 different colors. So looking at this as an English speaker, I think you would agree that some of these are what you'd call yellow and some of them are what you'd call green. Your task is to sort them into 2 different piles according to their category. All right. So in this particular pile, we have 2 colors which in English would be distinguished linguistically as yellow and green. You'd say that's green versus yellow. Here's another pile of chips. Now, as an English speaker, you're going to look at this and say, oh, they're all green. But for a Berinmo speaker, they're going to look at that and say, oh yeah, some of them are null and some of them are war. And then they're going to look at that first pile and say, oh, that's all null. So basically, for English speakers, the pile on the left cuts across categories. But for Berinmo speakers, it doesn't. For English speakers, the pile on the right is all within category. But for Berinmo speakers, they're in different categories. So now we're going to ask people to sort these things into piles, and we can look at how accurate they are and how long they take to do it. That's going to give us information about how they are perceiving the chips. If they perceive the chips as different, then they will be able to sort the chips faster, right? So the idea is that for English speakers, when you're sorting chips according to green versus yellow, that should be easy. But when you're trying to sort them according to these shades of green, then that should be hard. Whereas for Berinmo speakers, if their linguistic categories are affecting their thought and their perceptions, then we would expect that it's going to be hard for them to sort the things we would call green and yellow because for them it's all null. And it would be easy for them to sort the null versus war because it's across different categories. Okay, so now we're ready to look at the actual results from the experiment. We can actually see how long it takes them and how accurate they are in sorting these chips. Here's what we find. So what we have here is the time it takes, the number of attempts it takes to complete the task, in blue for English speakers and in brown for Berinmo speakers. You can see that when the chips use the null-war distinction, it takes the English speakers longer than the Berinmo speakers. So as predicted, it's actually harder for the English speakers to sort the null-war chips, but it's easier for the Berinmo speakers. On the other hand, when it comes to the yellow versus green chips, now it's harder for the Berinmo speakers and easier for the English speakers. So this does actually look like some interesting evidence that maybe our color categories change the way that we think and perceive these color chips, because when they're in different categories, according to your language, it's easier to sort. Here's another task that you can do in order to get at this question of whether linguistic categories affect the way you perceive and think about and remember colors. So here's a color. I don't know what you'd call this. I guess it's teal. It's something like, it's more on the side of blue, but it's really somewhere between blue and green. So the color recall task works like this. I show you a chip like this, a color chip. Then we wait 5 seconds. Okay. Now I show it to you again. Which one of these, left or right, was the one that I just showed you? Was it the one on the right or was it the one on the left? So let me know if you get it right. Can you remember? This is the color recall task. So you see a chip, you wait 5 seconds, and then you have to identify which one of two chips was the one that you saw. Which one was it? So the idea is that when those two chips I show you at the end are between categories within your language, when they are straddling a category boundary within your language, it should be easier for you to recall the chip. But when they are within a category, like when they're both just two shades of blue, it's going to be harder for you to identify which of the two chips was the one I showed you. This is another kind of test you can do to determine if the color categories affect basically the way people remember colors. And it turns out that you can get similar results that we saw with chip sorting using this task. So it turns out that when you are asking people to identify which of the two colors they saw, when those two colors straddle a linguistic boundary, so one is what you'd call green and one is what you'd call blue, then people are more accurate. So you can see here that people can identify the correct color with something like 80% accuracy when they are in different categories according to their language. But when those two chips were in the same category according to their language, then their accuracy is more like 67% or so. So across boundary, you have higher recognition accuracy. Within category, you have lower recognition accuracy. Here's another task you can use to get at related questions. So what we have here is actually 3 color chips in a row. And now one of them is the odd one out. There is a boundary here where you have one color chip and then followed by 2 other color chips of the same color. And so your job is to identify the edge. Where is the edge? So the idea here is that it's going to be easier to identify the edge when the 2 colors are in different categories in your language, and it'll be harder when they're in the same category in your language. In this case, it's probably pretty hard for you to see the edge, right? And that's because one of these is colored null and the other 2 are colored war, but they are all shades of blue, basically, according to English speakers. So here is another arrangement. Here we have null and null followed by war. Your job is to find the boundary. The idea is that it should be easier to find the boundary for things that are across categories in your language. So now here's a famous study which was carried out using this edge discrimination task. This uses the fact that the Russian language actually divides up the color space in a way which is different from the English language. So in the English language, these would all be considered shades of blue. They're all just shades of blue, right? But in the Russian language, these are not shades of the same color. These are actually part of different categories. In particular, the light blue ones are what would be called goluboy, and the dark blue ones are what would be called sini. So in Russian actually has a more fine-grained color system than English, where the blues have been split into light blue and dark blue. Goluboy is roughly light blue, sini is roughly dark blue. So we can conduct one of these edge discrimination tasks. We can show people a bunch of these colored chips. Some of them are going to be Sini, some of them are going to be Goluboy, and we can see whether the Russian speakers can distinguish the Goluboy versus Sini boundary faster than the English speakers. So here is some data from the experiments. So the brown bar shows the time it takes people to distinguish the edge when it is across categories. So in Russian, that would mean when one of them is Goluboy and the other one is Sini. In blue, we have the time it takes them to distinguish these colors when they are both within categories. So when both are Goluboy or both are Sini. It turns out that when the colors are in different categories in your language, so for Russian speakers in this case, you can pick out the odd chip about 100 milliseconds faster. So if those two colors are in different categories within your language, you can discriminate them, it seems, something like 100 milliseconds faster. This is actually a sort of quantitative view of the linguistic relativity hypothesis. If you're asking, what is the effect of language on thought? Well, it looks like it allows you to distinguish things maybe 100 milliseconds faster. I'd like to point out that 100 milliseconds is not a lot of time. That's the time it takes you to blink. So if you speak a language where these two colors are in different categories, you can identify the edge between them maybe about the time of an eye blink faster. Okay, but are people really seeing these colors differently? Is this really evidence that people are perceiving the colors differently, or is it maybe evidence that they are perhaps using the linguistic categories in order to aid their memory for these things? So maybe in that chip recall task, what's going on is that you see the two colors, you say one is green, one is blue, and then you just repeat that word to yourself over and over again in your head so that you can identify the color later. So it's like you see it, you say that, okay, that's green, and then you just say green, 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 green in your head until you're presented with the two chips, and then you pick the green one. So this strategy of sort of repeating a word to yourself in order to remember it is what we call the phonological loop. When you're remembering a word in this way, we say that it's stored in a phonological loop. This is an aspect of your working memory. So I look at this, I say, oh, well, this is blue, 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 blue. But let's actually see how we can maybe disrupt this use of the phonological loop. So maybe if we want to make it so that people cannot use the phonological loop to remember things, we can run the experiment like this. We can show people the chip, and so they're going to say to themselves blue, 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 blue. But then during the 5-second delay, you have to repeat back a bunch of words that the experimenter gives you. You have to read through a word list. And by doing that, you're going to fill up your phonological loop with those words. You're not going to be able to remember that word in your phonological loop. And then I show you the two color chips, and you're going to have to identify them based on your perception alone and not based at all on your linguistic categorization of them. So which one was it? So it turns out that this actually makes the effect of the linguistic category boundary go away. So remember, this is the evidence which shows that when the two chips are across category boundaries, you can recognize them more accurately. And when they are within category boundaries, you can not recognize them as accurately. When you add in this verbal interference, the difference goes away. The difference goes away. And so it looks like it's not that you are seeing the colors differently. It's more like you were recruiting your linguistic categories as an aid to your memory using your phonological loop. So this actually is a big qualification. It's a big limitation on this idea of linguistic relativity. It's not that your linguistic categories change what you see. Rather, it looks like your linguistic categories give you one tool that you can use to remember certain colors rather than others. We can do the same thing with the Russian blues experiment. So here, remember, we have this reaction time data, which shows that when those two colors of blue are across categories, one is Goluboy and one is Sini, then people recognize the edge faster. And when those two colors are within categories, maybe both Goluboy, then they're 100 milliseconds slower. Now we add the verbal interference. And Well, the first thing that happens is everyone gets slower at everything because it's just a more difficult task. But we also see that the difference between the colors that are within a color category and the colors that are across categories goes away. So when you add this verbal interference, now Russian speakers are no faster to identify Goloboy versus Sini than they are to identify two shades of Goloboy. All right, so we see that there does appear to be an effect of language on thought, but it's limited in this way. It doesn't change what you see. Rather, language gives you a strategy that you can use to remember things. So, are they really saying things differently, or are they just recruiting language in their phonological loop to remember things? It looks like it has to do with recruiting language in the phonological loop, and it doesn't have to do with perception. So it's not that you're seeing things differently, it's that you can use language to recognize things or to remember things a little bit faster. Words and language basically give you a tool. You can think about language as a sort of cognitive technology, which can aid your thinking, but doesn't fundamentally change your thinking. In this case, it gives you a tool for remembering certain colors. But it doesn't appear that your categories fundamentally alter how you see things. So, linguistic relativity, what is the status of this? In your head, you have thoughts, and you produce language. No question about that. How does language feed back to influence your thoughts? It appears that it does, although it is in this subtle and circumscribed way. Your language doesn't determine your thoughts. The current state of evidence is that language gives you a tool that you can use to enhance certain aspects of your thoughts.